This is number 5 on the mean value theorem worksheet, and our f of x equals x times x squared minus x minus 2 on the closed interval -1 to 1. So we want to see, does it apply? Well, we can multiply this out. And that's just x cubed minus x squared minus 2x. And this is all these are continuous functions, so this is definitely continuous. We could say that f of x is continuous. Actually, for all real numbers, so definitely it's continuous. On the closed interval, -1 to 1. And if we take the derivative f prime of x, that just equals 3x squared minus 2x minus 2. And that also looks differentiable. This is a nice smooth polynomial. So we can say that f prime of x, or f of x I should say, is differentiable. On the open interval, -1 to 1. So therefore the mean value theorem applies. So therefore we know that there exists some c that belongs to the open interval, -1 to 1, such that f prime of c equals f of b minus f of a all over b minus a. And again, this is our a, and that's our b. Those are the endpoints. So f prime of c, so what's f prime of c going to be? Well, f prime of c will be just this, so we would just have to put 3c squared minus 2c minus 2. And then we have to figure out what f of b is going to be, so we have to go back to our function. And what's f of 1 going to be? Well, it's nice, it's not too bad. F of 1 will be, if I put 1 in here, I've got 1 minus 1 is 0, minus 2, so it looks like that's going to be -2. And then f of -1, if I put that in, if I put -1 here, I get -1 minus +1 would be -2. And then -2 times -1 is +2, so 2 minus 2 would be 0. So I've got -2 minus 0 all over b, which is 1 minus -a. I'm sorry, minus a, which is -1. All right, so that's going to end up being -2 over 1, which is just going to be -2 over 2. All over, yes, 1 plus 1 is 2, which is just -1. So I've got 3c squared minus 2c minus 2 equals -1. So what's going to be the solution for that? What value of c will make that true? So I can just set this equal to this, and if I subtract 1, or if I add 1 to both sides, I got 3c squared minus 2c, and if I add 1 to both sides, I get -1 equals 0. So let's find out what's going to work there. So we have a nice, it's a general trinomial, but it's an easier one. So 3c and c, and we've got to have 1s here, so we just have to figure out our signs. That's the only way we can get 1. And if I put a positive here and a negative there, should that work? That's going to be 3c, and that's going to be, or 3c squared, that's going to be -3c plus c is -2c and -1, so that's what's going to work. So we have two possibilities here. 3c plus 1 equals 0, 3c equals -1, c equals -1/3, or c equals 1. All right, now we're looking for this open interval, so it has to be between -1 and 1. And it's got to be in the open interval. C equals 1 does not belong 1 does not belong to the open interval, -1, 1. But -1/3 does. So C equals -1/3. 1/3 does belong to the open interval, -1, 1. So we're good. So in this case, the value of C that will satisfy the mean value theorem over that interval, -1 to 1, would be -1/3. Okay? So again, you have to be careful on the nuances, all right? This is a good example of that. Okay. Now, if my interval was, a little bit wider, then we probably might be okay. Or if this was -1 to 2, then this would also work. Although that would probably change all this over here. So keep that in mind. So since, it's got to be the open interval. Okay, so watch this. Don't get confused there. We're looking for a point that belongs to the open interval for our value of C. That's what's guaranteed by the mean value theorem.